Is it recording?
Yes.
Okay, you can sit down now.
Choice one!
Was that authentic?
Gotta go right before he starts
How would you say it?
or else it'll get cut out.
I'm not gonna say it. Okay, are we getting the hang of this? It's really hard though. Oh, easy. That explains the long line for help this morning. Easy.
I know, right? That's huge.
It's not
Couldn't even get in the door today.
We're going over those numbers?
Yeah, those are all of them.
So yeah, that's all of them right there, ain't it? Yeah, number 6. I thought you guys were gonna say hi to Kamada and Yi. Hi, Kamada and Yi. And wait, there's somebody else missing.
Paulo's here.
Oh yeah, Paulo. Okay, 6. This is just like the one we did yesterday, right? You can't even be seen on the video.
I cannot. Where's the
You gotta
video?
come over here.
Oh, bro?
Hey, do Preston's thing.
No, don't.
I'm not touching it. I'm just looking.
follow you?
Oh, it's so close to the board.
How does
Wait, try put your hand up.
I wanna hurt you.
Oh, so violent.
Okay, what? Isn't this like the one I did yesterday, except this one's
Oh, I couldn't
easier?
even see me that whole time.
Now, I don't know if you guys noticed this, but the book hardly gives you any pictures, so did you guys notice on the website there's diagrams for these problems?
There is.
Yes.
Yeah, I saw it on the website.
Yeah, you don't need it, but then it just makes it easier, because probably on the quiz or the test I'm gonna draw diagrams for you. Okay, so again, this is like the one we did yesterday. We want to maximize the area of this rectangle, right?
Yes.
Does that sound familiar?
Yes.
It says, what is the largest area the rectangle can have and what are the dimensions? Probably if I were giving a quiz though, I would ask, find the coordinates of that point. To me, that's more interesting. Well, anyway, looking at this picture, what is the area of the rectangle?
2x.
2xy, just like yesterday, because that's x and that's y, but then you got 2 x's, right? But then again, we need to get rid of one of these variables because we only know how to take the derivative with one variable. So that's why you have to substitute in, and so y is equal to 12 minus x squared. So this represents the area of the rectangle. How do I find maximum? Take the derivative and make a number line. So if you multiply it out, you get 24x minus 2x cubed. Or would you rather use product rule?
No.
The problem is we can't multiply out again. So you take the derivative, which is 24 minus 6x squared. Factor out a 6, you get 4 minus x squared, and look how pretty that is. So make the number line. Don't forget to label now. On the quiz or test, that's automatic deduction if you don't label. So negative 2 and 2, how do I know it's minus plus minus? Okay, and then a is increasing, a is decreasing, and again, we only care, in this problem, it only makes sense if x is between 0 and the square root of 12, right? So the maximum area occurs when x is 2, so we say that x max is 2, and then you answer the question. Now, I'm not gonna, you guys answer the question, I just did all the hard work for you. Yeah.
So if you're trying to find max and your max comes up to -2, like you know how if it's plus minus plus, that means you did it wrong, yeah.
Say that again?
So like
If your number line is plus minus plus.
yeah, and
Then
you
that's
get a
wrong,
max
right?
with a -2, then you know it's wrong, yeah.
Yeah. But then again, the domain of this problem is this x coordinate, this point has to be somewhere along here, right? X has to be between 0 and the square root of 12, otherwise the problem doesn't even make sense. Okay, next. I can't believe we did that example yesterday. I mean, I can believe it. Oh, come on. You guys don't remember doing this problem last year? This is like the same problem. You have an 8 by 15 inch piece of paper, and then you're gonna cut congruent squares from the corners. So this is gonna be cut out this is gonna be cut out, that's gonna be cut out, that's gonna be cut out. And then you're gonna fold up the flaps like this, fold up the flaps, choom, 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 and you're gonna get like a rectangular box that looks like this. Do you guys see it?
Yes.
You're gonna be able to think three-dimensionally. So why don't we call this X? Because if you look at my diagram on the website, it has that, yeah? So if I fold up the flaps, we're trying to maximize the volume of the box, so we need to write a function for the volume. So if this is 15, and I take away X and X, what is this part right here? 15 minus 2X. If this is 8, and you take away X and X, what's this part right there? And then when you fold up the flap, what is the height of the box gonna be?
X.
X. So this is 8, no, this one is the smaller one. 8 minus 2X, 15 minus 2X. So isn't the volume of the box just length times width times height?
Yes.
Yes. 15 minus 2X, 8 minus 2X times X. And then all you have to do now is take the derivative and make a number line. Now what do you want to do? You want to use the product rule for three things or multiply it out? Okay, so if you multiply it out, let's see, what do you get? X times 120 minus 46x plus 4x squared, distributize the x, and you get 4x cubed minus 46x squared plus 120x, correct?
Yes.
Then you take the derivative, which is 12x squared minus 92x plus 120. And then you factor it. Can I factor out a 12? No. No. Can I factor out a 6?
Yes.
No.
No. Can I factor out a 4?
Yes.
Yes. So factor out a 4. 3x squared minus 23x plus 30. And is it factorable?
Yeah.
Yeah.
Okay, let's see. So 4 times 3x and x. 6, 5, 5, 6, 10, 3, 5, 6. Seems like 5. Oh, it is 5 and 6. 6 and 5, right? Because minus 18 and minus 5 give you negative 23. And so, number line time, b prime, so we got 5/3, 6, how do I know it's plus minus plus? Yeah, and there you go, and so volume is increasing, volume is decreasing, volume is increasing, so the maximum volume occurs right there. So x max is equal to 5/3, I will let you answer the question. So what was the problem with that? Exactly. That's the hardest part of the problem. Okay, next. 9. Where is 9? The best fencing plan. A rectangular plot of farmland. We did this problem last year. A rectangular plot of farmland will be bounded on one side by a river. So this is the river here, right here, like that. So you don't have to put a fence over there. And the other 3 sides by a single strand electric fence. And you have 800 meters of wire at your disposal. What is the largest area you can enclose? So shall we call this X and Y? So what are we trying to maximize in this problem?
Area.
The area of this rectangle. So the area is, if you look at the picture, X times Y. But the problem is you got 2 variables. You have to get rid of one, which means you need another equation. So is there another equation I can write?
800
Yeah, you have 800 feet of fencing. This plus this plus this, 2x plus y, gotta equal 800. And you can use that equation to get rid of one of these variables. So solve for one of the variables. Let's solve for y. Y equals 800 minus 2x. Take that and plug it in right there. X times 800 minus 2x. And there's your function. You guys don't remember doing this problem? This is what we call a classic problem. Every Algebra 2, pre-calculus, and calculus book has this problem in it. Okay, so shall we multiply it out then? Because you guys don't like product rule. Take the derivative and you got 800 minus 4x. Come on, that's senseless. 200 minus x. So when you make your number line, 200, and then it's going to be minus plus. So therefore, the area is increasing and then the area is decreasing. So maximum area occurs right there when x is 200. And then I will let you answer the question again. Come on, now it was simple. What's going to happen when we get to the harder ones when you got to use similar triangles and stuff? Number 10, the shortest fence. Okay, so it's kind of like the same thing. Except you have a rectangular pen, pea patch, and you're going to enclose it by a fence and divide it into 2 equal parts like this by another fence parallel to one of the sides. What dimensions for the outer rectangle will require the smallest total length of fence? Okay, so why don't we call this x, x, and x, and call this y? What are we trying to maximize or minimize in this problem? If you read.
The length of what?
The length of the fence. So what do you want to call it, L or F?
F.
Okay, F for fence, whatever. Okay, so look at this picture. What represents the length, amount of fence that you're going to use?
X.
No, 1, 2, 3x plus 2y. But again, we have 2 variables. We have to get rid of one of them. I need another equation. Do they give me more information? Yes, the area of the rectangle is 216 square meters or whatever it is. So look at this picture. What is the area of this rectangle?
X, Y.
X times y. That's got to equal 216. Solve for one of the variables. Y equals 216 over x. And plug it in right there. So you get 3x plus 2 times 216 over x. And then simplify that. 3x plus 432 over x. Okay, now the derivative gets a little more challenging. Take the derivative. I'll do the first one. 3. Who's got the second one? Who's got the second one?
Gosh. Negative
Holmes!
X times.
No!
Isn't it product or
Quotient? No, yeah, but 432 is a constant. You can throw it on the side like an unwanted pet.
So it's 1 over X.
And so what's the derivative of that? I told you guys to memorize that. Yes, you can.
Oh! Now I'm at negative 1 over X squared.
Okay, so
Negative
what-
X, negative
So what's the whole derivative? Negative?
432 over X squared.
Yeah. The derivative of 1 over x is negative 1 over x squared. It comes up so often, you want to just memorize it. Yes, you can use the quotient rule, but why? Throw the 432 on the side. Isn't this the same thing as her? At least do this. 432 times x to the negative 1 then, right?
Yeah.
Okay, whatever. Now, how do I make a number line for this? Look, I have fractions.
Factor.
But you gotta make a least common denominator first. So you're gonna have 3x squared. See, now this is where algebra is gonna come into play. Can I factor out a 3? Does 3 go into 432?
Yes.
Yes, how do you know?
Put the sum of the numbers.
Okay, so factor out a 3 and you get x squared minus 1.
20.
No.
Oh.
1.
44.
Okay. Anyway, you can kind of suspect it's going to be a square number, right? Whatever. Okay, so number line time. What goes on the number line? 0 and plus or minus 12. Okay, and then it's going to go plus, minus, minus, plus. I'm just saving time there. What? How come get 2 minuses around the 0?
Because it's,
Because it's got an even power, fool.
yeah.
Anyway, we really don't, that part there, we don't care about, right? Because we kind of have negative lengths in there, right? So, f is decreasing, f is increasing, so the minimum fencing occurs right there. X min is equal to 12. If you want to use a minimum amount of fence, then you make x 12. Now, next week we're going to have a quiz and then on the test, I'm going to try and make the answers come out nice. But sometimes, no can. Because that's just the way the problem is. Okay, we got 2 more and we're going. 11 and 13. 11. Your ironworks is going to jump into. Okay, so did you guys read? This is all reading. X, X, and Y. I believe I put that in my picture. Now, this is an open top rectangular tank now, there's no top. If you don't read that part, then it's gonna come out all ugly. The tank is, your job is to find the dimensions for the base and the height that will make the tank weigh as little as possible. So if we want this thing to weigh as little as possible, what are we trying to minimize? The surface area, that's right. Okay, so what's the surface area of this tank? I got a square on the bottom. What's the area of the square on the bottom? X squared. And what's the area of one of the sides, which is a rectangle? XY, but then you got 4 of them going around. So 4xy, that's the surface area, which is right directly related to the weight. But then again, you got 2 variables, you need another equation. Do they give me more information? Yes, it says the volume is to be 500 cubic feet. So look at this picture, what is the volume of this box?
X squared.
And that's gotta equal 500. Solve for y, just like all the other problems we did, and plug it in there. And we get x squared plus 4x times y. And then if you simplify this critter, you got x squared plus 2,000 over x. And then we take the derivative. Let's see if we learned anything from the last problem. 2x, and what's the derivative of 2,000 over x? To go.
Negative 2,000 over x squared.
Oh, you're money today. And then we make a least common denominator. Woo! So 2x cubed minus 2,000. Factor out the 2. Look how nice it's coming out. It's bringing tears to my eyes. Right? Because the cube root of 1,000 is 10. 10. So when you make your number line, you got 0 and 10 on the number line. Plug in a number bigger than 10, it's going to be positive, minus, minus, but we really don't care what's happening there. So right here, the area is decreasing, the area is increasing. So the minimum area occurs when x is 10. X min is 10, and then you answer the question. Are we getting the hang of it now? I hope so, because the problems are getting harder, you know. And then finally, last problem, number 13. Where are we? Designing a poster. How many people got this one? 1. 1. How many people actually read this problem? I want to hurt you. So you think this is good? The test, people, there's only 6 problems on the test. Only gonna get 3 problems from here. That means it's like 10 points a problem. You don't practice this. 1 problem and you come crashing down, baby. Don't worry, Mr. Park, I'm gonna clutch up. After Thanksgiving. Okay, you are designing a rectangular poster to contain 50 square inches of printing, but then you got a 4-inch margin at the top and bottom and a 2-inch margin at the side. So this is like 4, this is like 2. What overall dimensions will minimize the amount of paper being used? Okay, now, you guys understand what's happening? This is the paper out here, and this is like your print, whatever you're printing. You're trying to minimize the amount of paper being used, which is the whole thing, right? Okay, now you have 2 choices. Do you want to label this X and this Y? Or do you want to label this X and that Y? I mean, it really doesn't matter, that's why. Well, what would you do? Let's say you're on the test. You gotta pick something. It really doesn't matter.
X is the bottom one.
Okay, this is X and this is Y. Why did I erase it then? So, we're trying to minimize the amount of paper being used. The area of this poster. So, look at this picture. What's the area of the poster? X times Y. It's easy. But the problem is, got 2 variables. We got to get rid of one. I need another equation. Oh. Well, all we know is the amount of printing. This region has to be 50 square inches, right? 50 inches squared. Okay, so what equation can I write?
X minus 8.
Okay, so what are the dimensions of this inner rectangle? Well, if this is y, and this is 4, and this is 4, what is this right here? Y minus 8. And if this is x, and this is 2, and this is 2, what's this right here? X minus 4. So therefore, the area of the inside rectangle is x minus 4 times y minus 8. That has to equal 50. Now we have to solve for one of those letters. Maybe we should have done it the other way, Mr. Park. Yeah?
Yeah.
So you wanna, so see, now you realize something, so what do you wanna do? You wanna stop and change it or just plow on?
Stop and change.
I mean, it's up to you.
Stop and change it.
Whatever. Now I gotta erase. I hate you, Mr. Park. Oh yeah, I hate you then. Okay, so this is x and this is y. So what would this be? X plus 4, and this would be y plus 8. So the area of the poster then is actually x plus 4. And you really don't have to stop. Just plow on. Just the algebra just gets a little more involved. Okay, now the inside print gotta be 50 square inches, so x times y equal 50. And then see, it's easy to solve for the variable now. Yeah? Y equal 50 over x. Take that and plug it in right there. So now we're in business. X plus 4, 50 over x plus 8. Okay, now when you take the derivative of this, what do you want to do? Product rule or multiply it out?
Multiply it out.
Okay, just pick one and go with it. So derivative, oh yeah, we're multiplying it out. So if you multiply it out, I guess we're using FOIL. 50 plus 8x plus 200 over x plus 32. Did I do that correctly? Yes. Now we can take the derivative. Now, when you have the two constants here, that's going to be 0, so it's going to be a, and I'm not going to even call in somebody because we did that twice before already. The derivative of this is negative 200 over x squared. Make a least common denominator, which is?
8x squared.
No, just x squared, and you get 8x squared minus 200. Factor out the 8, so you get x squared minus what? Fill in the blank.
50.
No. 25. Oh, so when we make our number line, we're going to have 0 and plus or minus 5 on the number line. And it's going to be, plug in a number bigger than 5, like 6, it's going to be plus, minus, minus, plus. And again, it stays the same because you got an even power, but we really don't care about that part there. So, A is decreasing, A is increasing, so we have a minimum area when x is 5. So x min is 5, and then answer the question. I forget what the question was, but I'm not going to do everything for you. You guys can at least answer the question. Okay, so tonight's homework is the next 6 problems. It gets tougher. And then the last 6 are like, some of them are just going to blow you out of the water. So probably on the test, I would guess going to have like 2 mediums and 1 hard one. Not going to have any easy ones. Okay, we're done. We'll see you Monday then. There's 20 minutes remaining. Wait. Just in case the administration is watching, sit at your desk and finish the homework.